So let's talk a little bit about what this gene does. How big is this gene? How preserved is this gene over other species? And tell us a little bit about the protein that it codes for. What regulates it?
Sure. So Klotho itself is a pretty big protein. It's about 1,000 amino acids, and by weight, maybe 130 kilodaltons, if you look at it on a Western blot. And it codes for the aficionados, a type 1 transmembrane protein, which means that its N terminus will sit in the extracellular space. It has one pass through the membrane, and its C terminus is inside the cell. Now, the part that sits outside the cell has two repeat domains, KL1 and KL2. And those domains have high homology to proteins that are found throughout mammalian, worm, and fly biology. So they're homologs of Klotho throughout species and pretty conserved in mammals. So Klotho is a big protein. It's a transmembrane protein. And then what happens is there are a few forms of Klotho. It's made primarily in the kidney, also in the choroid plexus of the brain, but it's made in the cells of the kidney, and then it gets transported into the membrane. And then enzymes come across, base, atom 10, atom 17, and they clip that extracellular portion of Klotho and release it into the blood. Or in the case of the brain, release it into the CSF. And that form of Klotho is known as a soluble form of Klotho or the secreted form of Klotho. I call it a hormonal form of Klotho, the Klotho hormone, because it's released at one site and then can act at different sites at multiple organs. So that's how it's made. Those are the major forms.
So how big is that N-terminus piece that gets clipped that now goes and acts like a hormone, basically?
It's the majority of the protein itself. The part that's inside the cell and crosses the membrane is very small. So it's really the majority of the protein is the hormone itself.
If we were to, take a blood test and measure a person's Klotho levels, what could we observe about it across people of the same age, people of different ages? What factors do we think might influence the expression? And does the expression and production of the protein become the sole determinant of the soluble factor? In other words, is there also variability at the cleavage efficacy, or are there other factors that lead to consumption of the protein or degradation of the protein in the periphery?
Yeah, great questions. So starting with levels of Klotho across the lifespan. Well, Klotho is it circulates in us, it circulates in mice. And when we started our studies in mice, I really wanted to make sure that this was going to be relevant to the human condition, and it is very relevant to the human condition. And so we have circulating levels of Klotho. We're born with about 6 times the levels that we have now in our cord blood. And then throughout our lifespan, Klotho levels decline. And from, let's say, 40 onwards, they can decrease by half during aging. So we're born with very high levels and they decrease across our lifespan. They also have a circadian rhythm or a diurnal rhythm in that when we wake up, we have high levels of Klotho. And by 4 p.m., 3 p.m., when people are looking to grab a cup of coffee, the Klotho levels are really starting to decline. And then they nadir by around midnight. And it can be a 40% or so decrease. So there's a circadian rhythm to Klotho. It changes across the lifespan.
Sorry, Dena, just to make sure I understand that.
Yeah.
What explains the daily variation? Is it some sort of quote unquote consumption, or is it being turned over that quickly and the supply of Klotho is decreasing by the time of day?
Yeah, I think that's a great question. The answer to that is not known. What regulates the daily levels? How is it being degraded? Is the expression being increased? The half-life is short in mice, and in mice it's maybe 7 to 10 minutes. But in humans, well, I would say in monkeys, it's much longer. It's at least a day or so. So it's unlikely that the production is really actually increasing and decreasing, because when it's made, its half-life will be longer in non-human primates like us. So I would speculate, though I don't know, Peter, that it may be sequestered in organs or degraded, or not sure. I've seen a couple of reports of this diurnal variation, and it's really not clear why it's increasing and decreasing. But it is known in aging, for example, this longer term decline and slow decline that we see. It has been, it's been observed, and this was work by Fabrizia and Ambrosio's lab, that there is a hypermethylation around the Klotho promoter that occurs with aging that stops its transcription, and essentially transcription and translation. And so that's an interesting thing to think about if we wanted to preserve our Klotho levels. How can we interfere with that methylation that happens with aging?
That's interesting. So more methylation there leads to inhibition of the promoter. Yeah. And a lot of times you'll see the opposite, right? It's the loss of methylation that shuts off the promoter, correct?
I don't know. I don't know about that. In general, for Klotho at least, the methylation really turns things off.
Okay.
I could be wrong about that, but I think that's definitely the case with Klotho. I think that's definitely the case.
And is that believed to be the main mechanism driving the reduced production of Klotho, is the increase in the methylation of the promoter?
That's what's known so far. There are other possibilities, like maybe organs make it less. Maybe the kidney is less efficient at making it with aging. That's possible. But I think that Ambrosio's lab is really onto something. They showed it in chondrocytes and aging chondrocytes, but it's really the first kind of molecular demonstration about why Klotho may be decreasing. Now, there are other things, Peter, that decrease Klotho. And one big one is chronic stress. We did a study with Alyssa Eppel and Eric Prather here at UCSF, and mothers with neurodevelopmentally typical or atypical children. And the mothers with high levels of stress, with children with autism spectrum disorder, had much lower levels of Klotho, as well as shorter telomeres. And their level of stress, with increasing stress, there was a decrease in the Klotho level.
Did you demonstrate in those folks a higher degree of methylation of the promoter relative to their age? And did it basically look like they were older at the level of the promoter?
I think that would be so neat to look at. We haven't done that, but it would be really neat to look at.
So in other words, we don't yet know the mechanism by which chronic stress could be mediating the reduction.
That's right. There might be Ryan Brown here at UCSF and Eric Prather, and also Alyssa Eppel and myself, looked at whether there might be a relationship between Klotho levels and telomere length in these same women. And there is a very direct relationship with a very tight correlation between shorter telomeres and lower Klotho levels. So there may be some convergence around these different hallmarks of aging, maybe some relationship of them regulating each other, or maybe they're changing in parallel. It's hard to say. But here's some really good news. That in talking and thinking about what changes Klotho levels, we do know that stress associates with lower Klotho levels. But one of the most robust interventions that increases Klotho levels is exercise. It's been shown in study after study and in meta-analysis. It's been done in about 12 studies, but the data are that after 12 weeks of what people call chronic exercise, that Klotho levels increase by about 30%. And maybe even increase in a study with preliminary data. In mice, they can even double acutely after a 45-minute treadmill run. So, and how it's increased, like unknown, but it's beginning to be thought of as an exerkine, something that is produced and released in the body following exercise.
How would this stack up in your mind compared to something else that we would think of along these lines, BDNF, where, you know, I've talked about this at length on the podcast, of course, if you really look objectively at all of the modifiable behaviors around dementia, routinely exercise is at the absolute top of the list, more potent even in its magnitude than lipid management, glucose management, and hypertension, all of which themselves are enormously powerful. But something about exercise seems even greater. It could be that it indirectly mediates at least two of those three. But of course, people point to something else that's going on, and BDNF is often discussed. Do you think that maybe part of that effect is Klotho, and do you think that the effect of Klotho may be even more potent?
I was recently asked the same question at an Alzheimer's conference at the Salk Institute, and I don't know the answer, but I think it's a really important question. Is there a relationship between Klotho and BDNF? Does one mediate? Does Klotho increase BDNF levels in the brain? I don't know. BDNF has a very striking effect in the brain.
Maybe, Dena, just tell folks a bit about BDNF, because sometimes I forget that maybe not everybody listening to us today has also listened to all of the other content over the years. So maybe just give folks a little bit of a primer on BDNF as well.
Sure. So BDNF is brain-derived neurotrophic factor, and it has been shown in the brain to really be associated with even drive, like positive brain health. So intermittent fasting increases BDNF in the brain. Exercise increases BDNF. BDNF, if you give BDNF to the brain, the neurons function better. It's a really good trophic factor for the brain. And it does remind one of Klotho and effects of Klotho. And in fact, intermittent fasting simultaneously increases Klotho in the brains of mice along with BDNF.
How long do the mice need to fast to get that effect?
So this work was done at the Salk, and the mice fasted for 24 hours.
Wow. So not really something we can translate to humans, given that that's, I mean, 24 hours in a mouse is, you know, that's half the distance to death. So that's, you know, no, but this is a real problem. This is a real problem with extrapolating from mice data, right? Is even a 12-hour fast in a mouse is an overwhelming feat of calorie deprivation. 24 hours is staggering. I mean, we don't have a way to translate that to humans, but that it could be that that's on the order of weeks. So I just want to make sure people aren't listening to this thinking, hey, all I got to do is skip breakfast and I'm getting the same amount of BDNF or Klotho that I would get from a 45-minute workout. My guess is those two are not even in the same zip code, right?
Yeah. Well, I mean, so I think differently about it. So when I think about mouse time and mouse lifespan, I believe that they live to 2 to 3 years. But I believe that they're aging faster. They have a shorter lifespan. Sure. But I think it's possible that their 24-hour lives are similar to our 24-hour lives.
But they'll usually, you know, 48 hours of fasting will usually kill a mouse, right?
Would 48 hour? I don't know how long a mouse can go.
I used to be more facile with this literature, but I pay less and less attention to mouse literature now than I used to. But and maybe, obviously someone listening to this could write in and correct me, but I don't think it's a stretch to say that 48 hours, put it this way, what I do remember is an IRB would really scrutinize an investigator who's trying to get to 36 hours of fasting in a mouse. It's a really big deal.
We don't do fasting studies in mice, but I would agree that in general, we have to be careful when extrapolating from mice to humans. I do think that in the area of cognition and neurodegenerative diseases, that studying mice and mouse brains and their neural circuits and their hippocampi and their prefrontal cortices tell us fundamental things about the human condition. They particularly because they have to have very strong navigation strategies and memories for foraging, for coming back to their nests. And these memory circuits are very, very fundamental and quite preserved up to non-human primates, including us. But having said that, we do the majority of our work in mice, and we are always aware of, are we doing something that is important to the human condition? Is it relatable to the human condition? Is it relevant? Who cares? Will any of this matter? These are always on my mind, these questions, particularly as a physician scientist. And there are certainly limitations, but I also think that there are many strengths, particularly in studying memory and neural circuits in the brain. But we don't stop there. And we have tested whether, I haven't talked yet about what we have found in mice, but I'll just spill the beans and say that we found early on that Klotho enhances cognition in mouse brains. And in a very recent study, we collaborated with biotech and Yale University and found that actually Klotho enhances learning and memory and cognition in old monkeys, in a very complex brain, genetically diverse, anatomically diverse, functionally complex, that in a brain like ours, that Klotho had very similar effects to what we see in mice.
Well, there's so much I want to come back to on that topic because I've seen all of these data, of course, and truthfully, they seem overwhelmingly positive. But let's go back and kind of use some of the mice data to, allow us to speak about maybe greater insights around the causal relationship between Klotho and brain health. So we've already established a few facts here. So you're going back to the discovery of Klotho in 97, which was based on effectively a knockout. We saw that is incompatible with a long life. And we saw that the reverse, when Klotho was enhanced, I believe you said it enhanced lifespan by about 30%. Again, that's really remarkable in a mouse. There aren't many things that enhance a mouse lifespan by that much. That's, but again, that's up there with the most draconian caloric restriction, rapamycin administration under certain settings. So that's a very reproducible and robust finding. Let's talk a little bit about specifics to brain health, kind of what you're talking about with respect to not a disease state per se, but just enhancing cognition in an aging mouse or even in a middle-aged mouse.
This is where we started. And we started with the hypothesis that in these mice that overexpress Klotho, that live longer, that maybe these mice would be resilient to Alzheimer's toxins. That was our starting point. And so we back-crossed Alzheimer's models with Klotho overexpressing models to create mice who have Mouseheimer's and then have Mouseheimer's plus lots of Klotho. And then we had normal mice and normal mice with lots of Klotho. So there were 4 experimental groups. And to our complete surprise, the normal groups, that means we're not talking about the mice that had Alzheimer's, modeled Alzheimer's, but in the normal groups that had higher levels of Klotho versus normal levels of, that group showed a remarkable difference, a remarkable statistically significant difference across multiple cognitive tasks and across different ages. And that was that the mice that overexpressed Klotho, that lived longer, were smarter. So you put them in a maze. They could map the room better, escape quicker, not because they were swimming faster, not because they could see better, but because they were remembering and learning more efficiently and better. And that was a complete surprise. I remember the day, unblinding the data, analyzing it. It was unimaginable.
Can I add a point here? Dena, I just want to add a point. Sorry to interrupt, but it's so powerful. You, a moment ago, said this was statistically significant, which of course it was. And too often, I think people hear the term statistically significant, and I think they can be forgiven for confusing it with clinically significant. But as you know, those are not necessarily the same thing. And I almost think that in this case, Dena, stating that it is statistically significant, which it is, almost undersells what I think the magnitude of the differences are. I have a friend who likes to point out that the really powerful stuff in biology is the stuff that you don't actually need to do the statistics on. You know, when the delta is so big that you don't need to whip out the student t-test and calculate the p-value to make sure you're not being fooled, which, by the way, is very important and you should be doing it every time. But when it's actually just a formality because the answer is so clear looking at the data, that's the really big aha moment. And I think I'd be safe in saying that that was the case here, wasn't it?
You're right. You know, we tend to be really conservative. We don't want to make an error, but having said that, you're totally right. I mean, I can imagine the graphs now, and there were like non-overlapping data points, right? I didn't need to run the repeated measures between subjects, ANOVA, to really know that it was statistically significant. It was that type of a finding. So it's a point well made. But, you know, sometimes experiments will show you those differences, and then the next time you do it, they
That's
don't.
Right.
You know, someone who runs the water maze is wearing a new cologne, and the mice get stressed out, and it's not that the data don't repeat. I mean, they don't always repeat and are not always replicable. This is a case that it was amazing, but, you know, was it going to replicate? Was it going to be true in different cognitive tasks? What would happen in an aging mouse? Like, all of these questions opened up, and we iterated. And we did experiment after experiment, and the data held strong in mice that Klotho overexpression really enhanced their cognition. In young mice, in aging mice, in mice that modeled Alzheimer's disease, and also in mice in a publication that's in peer review now, but also in mice that model Parkinson's disease, that overexpression of Klotho enhanced cognition. And it is really a remarkable finding. I think it's one of it may be one of the most important findings in my professional career.
Well, I would go one step further. I feel like it's one of the most important findings in brain health, period. I mean, it's on some levels, it's a bit of a mystery to me why this isn't known by everyone. It's part of why I'm really, really happy to be sitting down with you, and why I've wanted to sit down with you for, you know, the better part of 6 months. And I know that between my schedule and yours, it took a minute to get us on the schedule, but this is such a big deal.